Imagine stepping onto a spaceship, and instead of floating about like astronauts on the International Space Station, you walk normally. Coffee stays in your mug. People sit at tables, and gravity feels just like Earth. Star Trek ships have it, Star Wars ships have it, and even huge space stations in movies have it. But here's the real question. Could artificial gravity actually exist, or is it pure science fiction? In today's episode of the Real Science of Sci-Fi, we're going to explore why astronauts lose bone density in space, the real physics that could create gravity on a spaceship, and the one artificial gravity design NASA might actually build. One of the biggest challenges of living in space is something most sci-fi shows completely ignore, and that's the fact that microgravity destroys the human body. On the International Space Station, the astronauts there experience muscle loss, bone density loss. They experience fluid shifting into the head, and they come back with a severely weakened immune system. After 6 months in orbit, astronauts can lose up to 20% of their muscle mass, and their bones lose calcium so quickly that the astronauts more closely resemble osteoporosis patients. That's why astronauts must exercise 2 hours every single day that they are in orbit. But even with this exercise, that damage still occurs. So if humans ever want to travel to Mars or beyond, we need a way to recreate gravity. Sci-fi usually solves this problem with something called artificial gravity. Ships like the USS Enterprise simply have gravity built into the floor. There's no spinning, no rockets, no visible machinery, just gravity. But that raises a fairly obvious question. Where does that gravity come from? Because according to physics, gravity isn't something you can just switch on. Gravity isn't a force like magnetism or electricity. According to Einstein's theory of relativity, gravity is the bending of space-time caused by mass. The Earth creates gravity because it's incredibly massive. In fact, Earth's mass is around 6 quadrillion kilograms. That's an enormous mass bending the space-time around it. And that curvature is what pulls us towards the ground. So if you wanted to create real gravity on a spaceship, you would need something with the same mass as a planet, which obviously isn't very practical. A spaceship the size of a city would still be far too small to generate any gravity. So does this mean artificial gravity is impossible? No, because there's another trick that physics allows us to play. Instead of creating gravity, you can fake it using acceleration. If a spaceship rotates, then everything inside gets pushed outwards. This is exactly the same force you feel on a spinning carnival ride, or when your car turns sharply round a bend. This outward force is called a centrifugal force. And if the rotation is fast enough, it can feel almost like gravity. In fact, the physics is identical to standing on Earth. Your feet are pushed against the floor, and the floor pushes back, creating the sensation of weight. Scientists have actually studied this idea for decades now. One famous design is the rotating wheel space station. Instead of a traditional spacecraft, imagine a giant rotating ring. The outer rim spins slowly, and the floor becomes the outer edge. People living on the inside of the ring would feel a gravitational force pulling them outward, exactly like standing on Earth. The larger the ring, the slower it would need to spin. And that matters, because if a station spins too fast, the people inside will experience another force as well. If artificial gravity is created by spinning, then your inner ear detects that rotation, and that can cause severe motion sickness. In really small rotating habitats, moving your head could feel like gravity changing direction. This effect is called the Coriolis force, and your brain would suddenly think the gravity is coming sideways or even diagonal. And this can make people extremely nauseous. Studies suggest that for artificial gravity to feel comfortable, A station would need to be at least 100 meters in diameter, preferably at least double that. And that's why in many sci-fis the stations are enormous rings. Some sci-fi films actually use realistic artificial gravity designs. For example, 2001 A Space Odyssey shows a rotating space station, and inside the ship Discovery 1, a rotating centrifuge provides gravity. Another example is the movie Interstellar, where the Endurance spacecraft spins to create gravity. These designs are surprisingly close to what real engineers propose, meaning Hollywood does occasionally get the science right. So, what are we actually planning on doing? Well, NASA has already experimented with artificial gravity concepts. Some proposals involve short-arm centrifuges inside spacecraft. Astronauts would spend a few hours per day inside a spinning chamber, generating artificial gravity temporarily. Other proposals involve tethered spacecraft. The two spacecraft, connected by a long cable, would spin around each other, creating artificial gravity without needing a massive structure. These designs are all still theoretical, but they could become reality for future Mars missions. So, could we build artificial gravity today? Technically, yes. There's nothing in physics preventing artificial gravity. The biggest challenges are engineering problems. Could we build a large rotating structure? Could we keep it stable? Could spacecraft dock safely? And could we prevent the structural integrity stress? But none of these problems are impossible. In fact, some experts believe the first rotating space stations could appear later this century, which means artificial gravity might one day move from science fiction to everyday space travel. So while the warp drives and teleporters of Star Trek may well remain fantasy, artificial gravity is different. It's based on real physics, and it might be essential if humanity ever wants to explore deep space. But that raises an even bigger question. If we can create gravity in space, what other sci-fi technologies might become real? If you enjoyed this episode, then subscribe for more Real Science of Sci-Fi with me, Dr. Dan Stokes.